Hey guys, today we are going to be looking at transformations and we're going to use Desmos to do it. So I actually have Desmos pulled up over here already, but if you do not, go ahead and open up the Desmos calculator website. It's really helpful if you work through this activity with me because it'll help you first get used to Desmos more, but then also to kind of let you discover transformations and how exactly they work. Okay. So first, let's talk about some of the basics of Desmos. So there's some instructions on here about what you can do with Desmos. And then we're going to be graphing equations in this section, and then the graph will pop up over here. Okay. There are two ways to graph with Desmos. So like I use my physical keyboard on my computer a lot because I'm really familiar with Desmos, but the other thing you can do is click on this little keyboard right down here and you can use anything that's on here as well. So if you're not as familiar with Desmos, this might be an okay use or idea. All right, so we're just going to follow the steps. Go ahead and graph the function or graph a function first. So I'm going to type y equals into the input box. And then I have a little angry exclamation mark. It used to be yellow, now it's just white. So it says if I have y equals and I don't type in anything else, I need something on both sides of the equals symbol. And so you can kind of fill that information in over here if you would like. I'm not going to because obviously I'm talking through it with you guys. But if you just try to graph this, nothing happens because you don't have a function. In general, if anything you type in the input section makes a little yellow triangle appear, it means that something is wrong with your function, your point, your line, etc. All right, so then let's finish off typing in this equation. So we got finish typing 2x plus 3, okay? And then we can sketch the graph of our function to our right. It doesn't have to be perfect, but it can be pretty close. So let's see, small on my paper. It's gonna be like right there, ish, okay? Next, we're going to learn how to add a slider because we're going to use that for the rest of this packet. In the first input box where I typed in 2x plus 3, I'm going to go ahead and delete that 3, and then I'm going to type in an h, and then click Add Slider. Oops, before I do that, let's talk about now it's an orange triangle. I have too many variables that are happening. And so now we're going to actually change that to a slider. And when we do that, we have this slider part pop up. If we click and hold the slider dot, what happens to our graph? Well, let's see. If I click and hold this until h is -2, we could say that our graph moved down 2. And so basically you're just changing your h with having to go in and type in individual values in there. Like instead of typing in 0 and then -2 and then -1, basically this is just letting me change my h and see what happens to my graph as my h changes. Okay, so those are the basics that you need in order to work Desmos. So I'm going to go ahead and I'm going to exit both of these inputs, and then we're going to start from scratch on the next page. All right, so the first thing we're going to discover are translations. And so it says graph the function f of x equals x squared in the first input box. So f of x equals x. And then you can either click on this little squared button right here, or you can hold Shift 6 on your keyboard and then hit 2. Okay, so there's f of x equals x squared. In the next input box, I'm going to graph g of x equals x minus k squared, and then plus h. And then I want my k and my h's to both be sliders, so I'm going to hit all. Okay. All right, so we're going to fill in, and see how I have two different graphs now? That means I'm doing it right. So we're going to go ahead and fill in each of the following sentences with the correct phrase. So when k equals 0 and h equals 0, so I'm going to change my k to 0 and then my h to 0. G of x, which is my black graph, how is it related to my f of x? Well, it's directly on f of x. That means that and that makes sense too, right? Because if k is 0 and h is 0, I could really just rewrite this as x squared. Okay, so I'll say directly on f of x. So, okay. When k is negative and h is 0, so let's make our k negative. G of x, I would say, is to the left of, right? See, it's over here now, so it's to the left of my purple graph. So to the left of f of x. when k is positive and h is 0, so let's make our k positive, then I would say g of x is to the right of f of x. There it is. And then now it wants my k to go back to 0. All right, so I'll do that. Now it wants me to change my h. So my k was inside of my x squared function, and when my k was negative, it made the whole thing move to the left, and when my k was positive, it made the whole thing move to the right. Now when k equals 0 and h is negative, so let's make h negative, g of x is, I would say, below f of x. And then when h is positive, you guys can probably guess what happens. Oh, it's above f of x. All right, last part, the variable k, which is, well, we just talked about this, inside the function. X squared moves our graph. Well, what did k do? K changed our graph and moved it left and right. So to the left and to the right. Our variable h, which was outside, see how it's not in the squared part, it's just tacked onto the end, moves our graph up and down. Awesome. So that's how translations work. If you have a variable inside of your function and it moves your graph left and right, and if it's outside, it's up and down. Let's go on to the next page, talk about reflections. All right, so we want some new, okay, we got some new stuff going on. So I'm gonna go ahead and get rid of all these inputs. Start. They give us f of x, and they want me to use absolute values. So x plus 4, this is my absolute value graph. Then it wants me to do g of x and negative absolute value x plus 4. And then it wants me to have h of x, another one, where it gives me, whoops, equals negative x plus 4. Oh, geez, this should not be the same color. Let's change the color of that one. At any point, if I want to hide one of my functions, click on the colored circle next to it. Okay, so for these first 3 problems, it looks like I'm only comparing f of x and g of x, so I'm going to go ahead and hide h. Oh, there we go. Okay. All right, so it says, which axis is f of x being flipped or reflected over to obtain g of x? So f of x is my purple one, and then if I flipped it, well, that means I flipped it over my x-axis. It went from being above to being below. What is causing this to happen in my equation? Well, the difference between f of x and g of x would be the negative out front. It's the only difference between those two things. Would I say that this is inside or outside my absolute value symbol? So I'd definitely say outside for sure. Okay. All right, let's go ahead and bring h of x back, and then I'm going to hide g. All right, so now which axis is f of x being flipped or reflected over to get h of x? Well, it was on the left side of my y-axis, and then it got flipped over to the right side, so I would say my y-axis. What's causing this to happen to my equation? The negative inside the absolute value symbols. Oh, and I would say it's inside, as I just answered that question. And so if I have a negative out front, that's a reflection over my x-axis, but I have a negative inside, that's a reflection over my y-axis. That's what I've learned from this little section here. All right, last part. Yep, we're going to stretch and shrink some functions. Okay. Oh man, I gotta go through, clear up this stuff again. All right, got x minus 2 to the 4th. Here's my first one. 10 x minus 2 to the 4th. And then I've got h of x equals 1/10 x minus 2 to the 4th. Beautiful. Okay, go ahead and hide h of x. Okay, my pleasure. Describe what happened to your function f of x when I added the 10 in front. So like when I multiplied by 10. Zoom in a little bit so you can kind of see what's going on here. So my function is the purple one. And so when I did the 10, my function, my black function is way skinnier than my purple one, right? So I would say that g of x is skinnier than f of x. When we multiply our entire function by a number out front, this causes a vertical stretch or shrink. So when this number is greater than 1, which is the case of g of x, did our function stretch or shrink from top to bottom? Now that's very important, from top to bottom. Did I take this purple graph and did I squish it vertically? So did I push from the top and the bottom towards like the middle, or did it look like I pulled it to make it skinnier? Well, it looked like I pulled my purple function so that from the bottom and from the top, kind of like you would stretch like a rubber band or something from the top and the bottom, and then it became skinnier. So I would say that I stretched it. I stretched my purple function vertically to get a skinnier g of x function. So I would say stretch. All right, now we're going to go ahead and hide g of x and then show h of x. When I describe what happened when I added the 1/10 out front. Well, my h of x is wider than f of x. Okay, this time we have a number from 0 to 1 multiplying our entire function, right? 1/10 is a nice fraction, so 0.1 is the decimal version of it. Has our function been stretched or shrunk from top to bottom? Top to bottom. I would say that if my purple function had been a rubber band, I would have squished it to make it wider, right? So I would have squished it to make a wider function. So I would say it shrunk vertically. Okay. We can also stretch or shrink our function horizontally. So I'm going to go ahead and make an adjustment. This happens when we multiply only our x value by a number like inside of the function. So let's go ahead and do that. So our first one is x squared plus 1. G of x is 5x squared plus 1. Notice how it's just the x is getting multiplied by 5 and not the 1. And then, oops, h of x is 1/5 x squared plus 1. Oh, geez. Zoom out a little more, I think. All right. So which function horizontally stretches f of x? So f of x is our purple one. Which one horizontally pulls it so that it gets wider? I would say my h of x does. Which function horizontally shrinks f of x? So I would say g of x does, because if my f of x is the purple one, if I shrunk it horizontally, if I squished it together, that's g of x is how I do that. Do the same rules apply for horizontal stretches or shrinks that apply for vertical stretches or shrinks regarding whether the number we're multiplying is greater than 1 or between 0 and 1? So the last question that we're trying to verify here is when your number was large, so when our number was 10 and I multiplied it out front, that was a vertical stretch. But here, my function h is the thing that's horizontally stretching it. So I think it's going to be the opposite, right? 1/5 isn't a large number. So we would say it's the opposite rules apply. So if you had, and you can write a little note or something for that, a vertical stretch and a shrink. So stretch would be like times 10, and then a vertical shrink would be like times 1/10. But for horizontal stretch, you'd have times 1/5, and a horizontal shrink would be times 5, right? So it's going to be the opposite as far as what a fraction does vertically and what a fraction does horizontally. Does it stretch it or does it shrink it? All right, we are going to kind of work with this a little bit more, but this was just an excellent discovery part for you guys to remember your transformations and kind of feel what they look like.